Hello everyone, thanks for coming to see our demo. We are group number 7 and our app is StoreFront. StoreFront is a mobile app that allows shoppers to easily find the products they're looking for in stores and store owners the ability to easily add their product selection for customers to search, thus saving them time and money. So without further ado, let us show you how this app works. So on the right, I'm mirroring my phone screen, and on the left we have our Firebase backend. We are using Firebase Cloud Functions to store our server-side code, Firebase Firestore as our NoSQL database, and Firebase Storage for storing images. So let's show you the process of using the app as a store owner. The first page they see is the login page. Once they fill this out and click login, this information is verified on the backend, which checks the credentials against the table of customers and passwords. Passwords encrypted, of course. So let's try the admin account with password as password. I spelled password wrong purposely to show you what happens if their login is invalid. Now let's spell it properly. And as you can see, this leads to successful login. We can check that our valid login function on the backend was called twice with these requests. Now the owner has two options. They can either edit the layout of their store or the store's product list. So let's click Store Layout. This page fetches the store layout of the store, which we have saved as a JSON string in our Firestore database. The gray tiles represent floor space, and the darker tiles represent shelves where store owners can add products. They can also view different floors of their store and add new floors if they exist. So let's add a new floor, floor number 2. And then let's add a row of shelves right here. Now, when we click Update Store, we can see the store layout updated on the back end as well. Now let's try adding a new product. Let's go back and click View Existing Products. Here we have the current product list for the store, which includes glasses, cups, pens, and so on. These products are stored in our separate table in our database, where they're given a unique ID, the quantity in the store, the location in the store, where the first digit indicates the floor number, and then the following two represent the coordinates, and also URL to the image of the product, which is hosted on our Firebase storage. Every time the product list is opened, it fetches this list from the database with our Get Products endpoint. So let's see how this works when the owner adds a new product. First, the owner can take a picture of the product. So let's say the product we are adding is an apple. First we take the picture, then we type the name as apple. Let's give it a quantity of 10, and then we can set the location to be on the shelves we recently added. Now, when we click Add Product, what this will do is it will send to our Add Product endpoint on the back end a JSON object of this information we have here, where name and location are sent as strings, quantity is sent as an integer, and the picture is sent as a base64 string. However, since base64 strings are a very inefficient way of representing images in our database and for when we fetch the product list every time, an important optimization we made was having our Add Product function on the back end first converting this base64 image string to an image file, then saving that in Firebase storage, which automatically provides a URL to view that image, and then in our database, saving the information for the picture as a URL instead of as a base64 string. So let's click Add and see how that works. As we can see, this product was added to the product list with this ID here. We should also be able to find that ID in the Firebase storage, right there. And to verify that the URL saved for this image is correct, we can open that right here. And as you can see, this is the image we just took. When the product list is fetched, this list is populated with the text received from the backend. And these images are rendered using Picasso, which is an Android library for efficiently loading images into the UI given a URL. Now, if I scroll down, we can find the apple in the product list. The store owner can also remove a product, of course. So let's remove pens from the product list, which of course updates the backend, as you see. Now let's use this app as a shopper. When we view the product list, we can see that pens are no longer in the list and our apple is available at the bottom. The user can then add products to their cart. So let's add a glass, a cup, and a wax hand. And let's use the search function for the last one. So let's search for the apple. Cool. All right, let's add that. Now when they want to see where the products are and the order in which to get them, they can click View Path. At the bottom, we are told which floors contain the products we are looking for, and we can see the location of them with the number ordering. The implementation of this algorithm will be discussed later in the video. Now let's go back and see how the path is recalculated. If we remove the apple from the shopping cart and add this Android doll instead, we can see now products are only on floors 0 and 1. And this concludes the in-depth demonstration of our app. We will now talk about the challenges we faced throughout the development process.
One of the major technical challenges we face with our application related to the synchronicity of our activities and the calls our application made, especially given the latency of retrieving information from a database. We ran into this challenge in multiple places, such as the authentication stage, loading the store layouts, as well as loading product lists for both shoppers and the owners. In order to address this, we created independent processes to pull the data from the database so that they weren't being done within the activity, and they were also being done before this information was required. Secondly, to provide feedback to our users, we added loading bars and screens for the users to be able to anticipate the amount of time it takes before the activity loads.
The challenge that we faced as a team was the shortest path algorithm for the items that are added to a cart and showing the individual customer where they are in the store. Initially, we planned to use an external API, but this proved to be too resource extensive. This is because Google Cloud Functions have a limited lifespan as they are spun up when the request is made and die after a certain period of time. As a result, we were required to implement a simple greedy algorithm. While it does not always provide the most optimal solution, it will always provide a solution for our customers.
One of the main challenges we had as a group was that one of our group members' development desktop was not able to make HTTP requests using the Android emulator, and this group member did not have an Android phone. This meant that the group member was unable to test any code they worked on and had to spend a lot of time trying to debug this issue with the emulator and the configurations, and ended up spending a lot of time that could have been spent on the app. So this was really mainly a challenge because it took a lot of development time away from the project, and it also created testing issues.